So everybody can hear me?
Yes.
Yes.
Yes, yes.
Okay. طيب بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف المرسلين نبينا محمد وعلى آله وصحبه أجمعين أما بعد. Your Excellency President of KFUPM, Dr. Muhammad Al-Saggaf, distinguished speakers, esteemed colleagues and attendees, ladies and gentlemen, Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, good afternoon, good evening, whatever the time zone you are in. My name is Ali Al-Sheikhi and I am the Dean of the College of Engineering at King Fahd University of Petroleum and Minerals, KFUPM. It gives me an immense pleasure and honor to welcome you all at the 16th Saudi Technical Exchange Meeting, STEM 2020. STEM serves as a leading regional forum for scientists and engineers from academia and industry to exchange and discuss the latest research findings in addressing real-world issues. STEM 2020 is organized this year for a very important topic, which is clean energy. R&D in clean energy is extremely needed to lower energy costs, reduce carbon emissions, and improve our lives. This is why the theme of this forum is R&D in clean energy, challenges and opportunity. On behalf of the organizing committee of the College of Engineering at KFUPM, I would like to thank our distinguished speakers from all around the globe. Mr. Ahmed Al-Khwaiter, Saudi Aramco Chief Technical Officer, Dr. Bob Mahoun, Executive Vice President, Sustainability, Technology and Innovation, SABIC, Saudi Arabia, Professor Mohammed Naziruddin, Swiss Federal Institute of Technology in Lausanne, Switzerland, Professor Martin Green, University of New South Wales, Australia, Professor Ibrahim Denser, Ontario Tech University, Canada, Professor Mike McGee, University of Colorado Boulder, USA, Professor Fausto Pedro Garcia Marquez, University of Castilla-La Mancha, Spain, Professor Akhtar Kalam, Victoria University of Australia, Professor Fahad Suleiman, and Professor Fahad Al-Harbi from KFUPM. I'd like also to thank the sponsor of this forum, which are KFUPM Institute for Knowledge Exchange, KFUPM Sustainability and Renewable Energy Master Program, and the IEEE Saudi section. I extend my thanks and appreciation to the Technical Organizing Committee of the College of Engineering at KFUPM, Professor Muhammad Darish, Electrical Engineering, Professor Atiyah Khalifa, Mechanical Engineering, Professor Shamshad Ahmed, Civil Engineering, Professor Naif Qasim, Aerospace Engineering, Professor Isam Al-Jundi, Chemical Engineering, Professor Muhammad Abido, Electrical Engineering, Professor Khalid Mazghani, Mechanical Engineering. I really wish everyone a successful and fruitful forum. Allow me now to give the floor to the President of KFUPM, Dr. Muhammad Al-Saggaf, for his inauguration remarks and address. Floor is yours, Dr. Muhammad.
Okay, بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. Good morning, good afternoon, good evening, everybody, wherever you are, just like Dr. Ali has mentioned. It is truly my pleasure to participate in this meeting. I think meetings like this one really disseminate knowledge and allow establishing bridges from scientists and engineers and faculty, professors of various ranks across the globe. And their outcomes are immense, not only in terms of the outcomes themselves, but in what they foster in terms of collaboration, knowing about each other and meeting each other and so on. So I thank Dr. Ali Sheikhi and the organizing committee for the meeting, and I also thank them for inviting me to participate in the first session. And I'm going to keep my remarks as brief as possible and talk only about two things. Number one, that energy is really the foundation of today's civilization. Anything that you need to do, from sending an astronaut to the moon to operating equipment in an operating theater in a hospital, to lighting classrooms for students to study, everything that you need to achieve in today's civilization requires energy. Even social processes many times require energy. And therefore, energy is a fundamental driver in today's activities. And the trick, of course, is to ensure that the use and benefit of energy comes without undermining any other aspects of our life, including the environment and maintaining the planet and so on. And hence, today's meeting is one that is very important, because research in clean energy would allow us to have both aspects of what I have mentioned, access to this important driver of life, and at the same time not negatively impacting any other aspects of life. So today's meeting is indeed one that is important. I mean, humanity, society in general, has been grappling with the right balance between these two issues that I have mentioned, and I look forward to debates and discussions and lessons learned in today's meeting, which I think will enrich the overall discussion in this topic, and we'll find hopefully opportunities and solutions to achieve that difficult balance. The second aspect of what I'd like to discuss is what is happening at KFUPM. KFUPM became independent about a year ago, and we have been working very hard to make sure that it really advances very, very quickly to become truly a global institution that is recognized worldwide for its excellence. And we have been rather silent. I mean, many people would not know what has been going on, because we are really not into making promises that might not become realities, and rather talk about what was achieved rather than what is going to be achieved. Although a little bit of what we aspire to achieve does not hurt. And so I'm going to go very quickly over some of the things that we are doing. I think today's conference is an important medium to disseminate some information, and also to tell you what we are becoming, so that opportunities for further collaboration can be enhanced and enriched. As I said, the university became an independent institution about a year ago, and it set out with the mandate of facilitating the transition of the economy of Saudi Arabia from a resource monetizing economy based on oil and gas into truly a diversified knowledge economy, and to help the kingdom become not only a participant, but a competitor in the rapidly evolving digital economy of the world. And so that is really the objective of the transformation of KFUPM, and we therefore set out to do many things. First of all, we have had fantastic programs at the university for over 60 years, but over time they have become classical, and we wanted to renew them such that they are not only suitable for today, but suitable for tomorrow. So we overhauled all of our academic programs. All 35 academic programs at the university, from electrical engineering to petroleum engineering to mathematics and architectural engineering and finance and so on, were overhauled to be based on an AI plus X foundation, i.e., this will be the foundation that every student coming out of the university will have been grounded onto. So what did we do? We added courses in modern programming, such as Python. We added a course in data science, including big data and optimization and everything related to the handling and optimization and the use of data in data science, a course in artificial intelligence and machine learning, including neural networks and all the applications and fuzzy logic and so on, a course in business, including managerial accounting and finance, and in entrepreneurship, including how to start a venture and the seed rounds and the minimum viable product and so on, and a course in career essentials. And all of these represent the new AI plus X foundation that every student takes at the university, no exception, and they take them together in an environment that is mixed between the disciplines. So we established this common language and common foundation. And then we said that within our departments and majors, we need to go into specialization early on such that our students hit the ground running. So we introduced 20 new undergraduate concentrations in many things, from artificial intelligence, cybersecurity, robotics, to data analytics, quantum computing, hydrogen mobility, and so on, and became very popular. Nearly 400 students enrolled in these. And so you graduate not only with a degree in computer science, but with a specialization in cybersecurity or some other specialty. And our students who are already distinguished in the marketplace and the job market will have an even bigger halo, I think, because they will have an edge over everybody else who is competing for jobs with them. And then we said that in order to truly activate the economy, we need to activate this layer of professionals who aim to improve themselves, to enhance their performance, or go to the market and establish new startups and so on. So we created 15 new professional master programs that we call the MX programs, again in similar topics, from artificial intelligence to supply chain management to wireless communication and so on. And it was a very, very popular initiative. It was 10x oversubscribed, and is going on very well. It's a 1-year full-time program. And we hope that those students will then, like I said, participate in uplifting and diversifying the economy, because this layer is one that has not been served sufficiently by the university over the past history. And this was also the first time the university opened its programs to both genders on a meritorious manner. And in fact, about 20% of the students in these programs are female. We then said that we need to upgrade the way we teach our students. I mean, many studies have shown that classical teaching methods result in very low retention levels by the students, as low as 5%. And so how can we move into data-driven and experiment-driven and inquiry-driven learning? And some of these are not new methods, but they are not being effectively used in our region. And so we are going into them big time, and all of them purport to, instead of just lecturing a student, asking them to research something and using the class time then for debates and discussions and questions. And so the retention is, especially that nowadays, I mean, you just say something to Google and you get the result. And unlike, and I am an alum of KFUPM. I entered in 1984, and at the time I wanted to do a paper on Chernobyl, and I remember waiting weeks for references, going to the microfiche section of the library. Those who are old enough will remember it, and it was a hassle just to get some basic information on what has happened. And so we experimented with this in the summer, was very successful, and now 20 courses or so will start in the next semester using this, and for this to become a competitive advantage for the university. And then one of the most important aspects of the university is research, and we are completely restructuring our research programs, in fact, overhauling them to be based on interdisciplinary research, to emphasize not only pure and applied, but research to market. Our goal is to amplify the impact on society, to help improve the human condition. And so we are just at the brink of launching this restructuring. We have been working on it for the past several months. And so all of our centers will become interdisciplinary centers that are focused on important topics. The first centers that we are now planning to launch are the Interdisciplinary Center for Advanced Materials, which will focus on new materials, non-metallics, on applications in pipelines and packaging and construction, material degradation, and so on, and has some important goals of can we use new materials, for example, in repairs in construction to double the longevity of our houses, or can we extend the working parameters of polymers and ceramics to withstand twice harsher pipeline conditions, whether sour surface or pressure and size, and so completely eliminate traditional pipeline degradation of metallic pipelines? Can we develop material for food packaging that automatically changes to depict the food spoilage, and thus avoiding nearly 20 to 30% of food that is thrown out because it has passed its expiration date, but it has not spoiled, or to avoid food that has prematurely spoiled and to be used? Can we use CO2 to effectively reduce the cost of things like carbon fiber for a true circular economy, and so on? What material can be utilized to quadruple the storage capacity of large-scale battery storage, which is relevant to today's meeting, and so on? Each of these centers will have faculty from across the university. In fact, every faculty in the university will be jointly appointed to one of the 20 or so centers that we will be launching, but we are going to do it gradually. The other center is the Interdisciplinary Center for Intelligent Manufacturing and Robotics, tackling things like advanced manufacturing techniques, automation, additive manufacturing, 3D printing, and applications in construction, and so on. Robots that are intelligent, the industrial artificial intelligence and robotics, and so on and so forth. And to have all of this in order to, like I said, improve the human condition. And the third one is the Interdisciplinary Center for Membranes and Water Security, looking at membranes for water and other purposes, but looking into things like water desalination, water pollution, water purification, water resources, effective use of water, reuse of water, waste management, and so on and so forth. And the fourth one is the Interdisciplinary Center for Intelligent Secure Systems, in which it will attempt to effectively apply artificial intelligence and big data and smart security, advanced facial recognition that goes into emotional interpretation, such that we identify a terrorist before he does something rather than roll the tape after the fact. So identify from the face the intent of birth, especially if when you have big data with repetitive recording of their faces over time. Advanced surveillance, intruder detection, the use of new sensors such as LiDAR to improve these aspects like intruder detection and so on. Cybersecurity and all of its applications, secure financial transactions and blockchains, smart crowd management, and so on and so forth. And the fifth one is the Interdisciplinary Center for Future Mobility and Logistics, which focuses on advanced supply chain management, integrated logistics, on making the kingdom perhaps to take the step of becoming really a center for logistics, especially it is blessed with a fantastic location and an openness in terms of its regulations, modern logistics, traffic planning and city design, autonomous vehicles, smart cities, applications of AI in ride sharing, and so on and so forth. So we are very pleased with this. We are bullish on reaching our goal of quadrupling the research output, the annual research output of the university over the next few years. And the last item I like to mention is that we have a very strong push for startups. We started the Dhahran Techno Valley Challenge a few months ago. It attracted about 120 ideas. 4 of them are already in the market. We provide incubation, even seed money, shared resources, whether legal and so on and so forth. And we are really quite intent on opening this avenue for our researchers, for our faculty, to make them own and these startups, to make millionaires out of them if these startups are successful. And finally, in fact, finally is to really open to the world. The KFUPM Institute for Knowledge Exchange, or KICS, was an important aspect of making sure, and this is something we started, but we are doing it very gradually. I think we need to be faster. We want KFUPM to be a hub for discussion, especially that this pandemic has shown us that you don't need physical proximity to participate in effective meetings. In fact, at the university, all our meetings are through Zoom, even with people next door, because it's just more effective. You can pull a slide, you can annotate, you can do many things you cannot do. And if you get bored, you just turn off the camera and take a break and did the meeting, which unfortunately I cannot do most of the time because I run the meetings, but I know my colleagues tend to do that from time to time. KFUPM is now ranked 10th in petroleum engineering. It's ranked number 84 in chemical engineering, and it's ranked number 4 in the number of US registered patents last year. And we are really intent on making sure this transformation is an effective transformation without a lot of fanfare, to do it silently. And this is a very narrow, small, like-minded group. I can talk with a lot of candidness, but we are not really into big media, circus and talking and so on, and inflating things that actually did not happen. But we are intent on making sure this university will take very quick and very effective and very big steps towards establishing it as a go-to global university, serving not only the kingdom and the region, but truly serving humanity and society at large. Thank you again very much for giving me this opportunity, and I wish you a very effective and informative and enjoyable meeting. Thank you very much.
Thank you, Dr. Muhammad, for these remarks. I'd like just to draw the attention of the attendees that you can write down your questions and answer in the window that appears at the webinar Q&A. So you can please write down your question and answer. Maybe we can take a couple of questions at the end of this session. Our next speaker of this first session is Mr. Ahmed Al-Khwaiter. Mr. Ahmed Al-Khwaiter is Saudi Aramco's Chief Technology Officer. He joined Saudi Aramco in 1983, where he held various technical roles in oil and gas production organization, ranging from design, project management, commissioning, and operation, as well as a number of supervisory, managerial, and general management positions. He held the position of Saudi Aramco Chief Engineer from 2011 to 2014, and Executive Director of Power System in 2014 before assuming his present role. Mr. Al-Khwaiter holds a BS degree in Chemical Engineering from King Fahd University of Petroleum and Mineral, and an MS degree in Chemical Engineering from the University of California, Santa Barbara, and an MBA degree as a Sloan Fellow from MIT. The title of Ahmed's talk is Industry Academic R&D Collaboration is Key to Unlocking the Full Potential of the Circular Carbon Economy. Floor is yours, Mr. Ahmed.
Great, thank you, Dr. Ali, and of course, Dr. Sagaf. It was great to hear your vision for the future of KFUPM. And we look forward to it, of course, as we benefit from the outputs of KFUPM tremendously. As you know, many of our people, many of our employees, yourself, myself, all came through that incredible hill above the Dhahran. And we look forward to seeing it to actually excel and really demonstrate the value that it has for us so many years around the world. The topic of, or the title of my talk will be about industry academic collaboration and the necessity of that collaboration. So if you can move to the next slide, please. Next slide, yes. So one area which has really been a challenge, I think, for academia is really understanding what is, where they can have impact. And I think that this great event that occurred in the last year, where Saudi Arabia was able to share its vision for sustainable energy and a sustainable path to, or a path to sustainable energy system in the form of what is called a circular carbon economy, which was endorsed just last November by the G20 leaders. And it was a tremendous win, I think, for both the kingdom, but also I think the world, because this allows alignment of all those who wish to see a future for for our generations that is sustainable, but also equitable. And this alignment, this framework is going to serve many, many purposes. In addition to allowing industry and government to really identify the necessary initiatives or necessary actions and investments that need to occur to achieve a future sustainable energy system, it also sends important signals to academia of how to contribute to this challenge. If you move to the next slide, please. Next, yes. So the circular carbon economy framework is useful because it is simple, but still relevant. And I think this holistic, pragmatic approach allows academia, industry, and government to understand how they can all contribute to a sustainable system. And if you look at the basic elements, the 4 elements, reducing emissions, and that's been really the focus of the world for the last, I would say, 20 years. But what's exciting about this is that as we reduce emissions, we have realized as a world that it becomes extremely expensive to reduce alone, when in fact, many areas of the energy system, many parts of the energy system can only be reduced their emissions if we find other means that are more economic, such as reusing those emissions or recycling them into valuable products, and finally, removing those emissions from the atmosphere. Next slide. So, as we know, there are many challenges to achieving such a system. And it's going to take many enablers. Of those, of course, policy is first. Policy is critical to set the tone and to allow the kind of investments and infrastructure that needs to be put in place. But I think at the base of this, there is a belief that technology is the key enabler. Policy, infrastructure, investments, advocacy, all of that can only happen when we have the right technology. So move to the next slide, please. This is a slide from the International Energy Agency, which shows their views on in the technology outlook, that in order for the world to achieve the reduction of emissions, the majority of the technologies needed are not yet mature. The vast 75% are either in early adoption or demonstration or prototype, which means that technology is the key for the world to achieve its emissions targets. 75% needs technology today. If we move to the next slide. Next slide. So because of the time-sensitive nature of the challenge of the energy or the climate challenge, we need to revisit the way we innovate and focus on the entire value chain in order to accelerate the development of those technologies. We need, in order to do that, we need interdisciplinary synergies, and we need to address the grand challenges So there's just a whole range of, I would say, technology challenges that are needed to be addressed over the next 20 years. Next slide. To give some examples, here we can see this tree from the US National Petroleum Council, which shows the wide variety of low carbon products that can be made from CO2. So if we choose to reuse or reuse, for example, CO2 as a working fluid in EOR, enhanced oil recovery, or fracturing, or geothermal energy, or if we want to recycle through biomass or through synthetic chemicals, just so many options. But what defines most of these options is that they're very early in their development. And there's a tremendous opportunity for R&D and for academic research in these topics, because we can see there's going to be huge value on the capture, reuse, and removal of CO2. And that will then fund research around the world. And this is a golden opportunity for academia to play a role in really solving the world's biggest challenge today. So there are many conversion routes, for example, for CO2. We see thermochemical routes, electrochemical routes, photochemical routes, mineralization, biological routes. And there are a lot of challenges with that CO2. In the case of, for example, atmospheric CO2, it's very low concentration. So all of these challenges are ideal for basic fundamental research. Next slide. So I just want to use one example. If you go to the next slide. So electrochemistry. So one of the very exciting developments in energy today is the fact that renewable energy has reached what I would say is, at one time they used to say nuclear energy would be too cheap to meter. In fact, that didn't really happen with nuclear, but it is happening with solar. As we see in the kingdom, we have achieved in one project, in several projects, below 2 cents a kilowatt hour electricity. In one case, I believe in the UAE, there's a project that is being awarded at 1.4 cents a kilowatt hour. These are incredibly low prices for electrons. For the first time in history, we are getting electricity, energy in the form of electricity, cheaper than natural resources. This is going to revolutionize the energy industry, but as well, I would say, the chemical industry and many other industries. And that is mainly through electrochemistry, because electrochemistry then allows those electrons to be utilized in industries and parts of the economy where they were not utilized before. For example, through electrolyzers, we can produce hydrogen. Hydrogen can become feedstocks for chemicals combined with CO2. We have opportunities to use, for example, electricity, of course, in electrochemical batteries for energy storage. So just tremendous opportunities for research. And I just list a number here. Of course, CO2 conversion, hydrogen, the whole hydrogen economy, fuel cells, carbon capture, just so many applications that electrochemistry is going to play a role. And we see that today in the form of, for example, the battery industry, the lithium-ion battery industry, tremendous new industry, which 20 years ago didn't exist. We're seeing huge growth in electrochemistry across the board. And what's new is electrochemistry traditionally was recognized as in the electrical field, basically, in batteries and electron storage of electrons. But to see electrochemistry applied to production of chemicals, ethylene, and of course, electrochemical production, reverse water gas shift of methane. So there's many, many opportunities to take electrochemistry beyond batteries and electrical grids and into the chemical industry. And this is what I think is an area of an opportunity for academic research programs around the world. We're seeing this, and we think that there's a confluence of trends or confluence of, I would say, opportunities. One is the low cost of renewable electricity. The other is the tremendous demand of decarbonization, which is happening around the world in all the commitments of all these countries. And finally, I think a lot of new material science enabled by AI, as Dr. Sagaf mentioned. Those three factors are going to revolutionize the electrochemistry field and turn it from I would say, a niche kind of in the industry to probably one of the major contributors to industry in terms of sources of materials and chemicals. Next, please. Next slide. Another promising area of application in the circular carbon economy is going to be carbon capture. There has to be, and this is validated by the International Panel on Climate Change, the IPCC, in the majority of their scenarios, require some form of negative emissions, carbon capture and removal of CO2 from the atmosphere in order to achieve the 2-degree or the 1.5 degree ambition, which means that we cannot achieve the Paris Agreement objectives in the majority of scenarios unless we apply carbon capture at an industrial scale. And so the technologies that can improve and reduce the costs of carbon capture are all going to be essential technologies in the next 30 years. And the use of the carbon in the form of either recycling in the form of fuels or CO2-based chemicals, all of those will be technologies that are going to be needed in the future circular carbon framework. Next slide. So I did mention that, of course, carbon capture is really critical. But I think also, as Dr. Sagaf mentioned, one of the key enablers will be materials, whether they're non-metallic materials, whether they're MOFs, metal organic frameworks that enable chemical reactions as catalysts or as storage materials, whether the lightweighting of materials to reduce energy consumption and transport, wind turbines, just the materials are going to be the enablers, whether as a form of a catalyst, a storage material, or a structural material. All of these materials are going to be enabled also by advanced technology or advanced techniques and advanced approaches to discovery. So material discovery, and especially AI-based material discovery, is, I think, one of the most exciting developments in R&D today. We see, of course, robotic-based high-throughput experimentation that has really revolutionized and accelerated the development of new materials. However, that is really just accelerating our existing trial and error process. What is more exciting and can have an exponential impact is to apply AI data-based approaches to really homing in to the right materials, to the right material combinations with AI approaches or big database approaches, coupled with the robotic experimentation to really accelerate. So technologies that we had developed in the past over a period of 20 years can be accelerated to 1 or 2 years. And that's what the singularity, I believe, in materials research will deliver. Next slide. Another area very important for the circular carbon economy will actually be data collection and data analysis, because it is essential that life cycle assessment be utilized in any kind of policy that needs to be applied to a circular carbon approach. And that data analysis will require new technologies, data technologies such as blockchains and I would say fintech approaches that could allow the monetization of the reduction of carbon footprint across the value chain. Today, we have no easy means of pricing these reductions of emissions across the supply chain. And that is an area where I think the financial research, the business type research can really play a role in how to create new economic systems which value the reduction of emissions. Next slide. So we have in Aramco, of course, a large number of programs that were basically contributing to the circular carbon economy, and we look forward to collaborating with academia. We are collaborating both with KFUPM, KAUST, and around the world in many areas of that really enable the circular carbon economy. Carbon capture, of course, is perhaps the biggest area where we are working, but efficiency, engine efficiency, is also a major area where we are looking at and working with many automakers and universities as well. Next slide. So that's the end of my presentation. I hope I was able to give you a bit of some of the excitement that I have around the trends in R&D, which I think are most relevant to the future of the sustainable energy system, and I'm open to any questions you have.
Thank you very much, Mr. Ahmed. This was really excellent presentation and give us an idea about what Aramco is interested in. We will maybe take a couple of questions at the end of the session, but our next speaker will be Dr. Bob Mahoon. Dr. Bob Mahoon is the Executive Vice President, Sustainability, Technology and Innovation, and Chief Technology and Sustainability Officer at SABIC. He oversees a global organization with 20 research centers around the world and a talented team focused on driving process, product, and application innovation to support SABIC's growth agenda. Additionally, Mahoon has responsibility for corporate sustainability, product stewardship, technology licensing, and technology ventures. Dr. Mahoon joined SABIC after a 21-year career at Dow. He serves as a board member of the University of Michigan Engineering Leadership Advisory Board and Aspen Tech Executive Advisory Board. Dr. Mahoon earned his bachelor degree in chemistry from Rice University and his PhD in organic chemistry from California Institute of Technology. The title of Bob's talk is Delivering on the Circular Carbon Economy Ambition for the Chemical Industry, Opportunity, Challenges, and Support Needed. The floor is yours, Dr. Bob.
Can you hear me okay?
Yes, we can.
Okay, wonderful. Thank you. And thank you to you and Dr. Sagaf and the organizers and everyone else involved. It's really just an honor to be able to participate here. One, because of the strategic partnership that we have with KFUPM, both for research as well as the great talent that we bring into SABIC, but as well because it's such a timely topic. Renewable energy, as I think really aptly highlighted by Dr. Sagaf and yourself and Ahmed in his presentation, really is going to be key to addressing the circular carbon economy challenges. And so that's really what I wanted to talk about today, is from the chemical industry perspective. And I think you heard Ahmed mention this, that for the chemical industry itself, it will be a critical enabler. Delivering on the circular carbon economy ambition for the chemical industry, opportunities, challenges, and really the support needed from academics, from policy, from infrastructure, and we'll talk through all those things. So just as a quick overview, who are we in the chemical industry and what do we do, right? We take traditional feedstocks, so this is ever evolving, but of course built off a history of crude oil, gas, and coal. We take those through process technologies, through steam crackers, through reformers, through MTO technology and others. We're integrated with refineries for access to feedstocks as well. And we use that to build the building blocks that our industry uses. Products like ethylene, propylene, benzene, other aromatics, syngas. And that's what's used to make the products that we sell, which then are touching the value chain in many different places. But they all are tied to these very common feedstock intermediates. The industry is going through a rapidly changing environment. And really that's one of the reasons why the focus on the circular carbon economy and the focus of the G20 was so essential. So what's happening? Well, the consumer and NGOs are providing pressure now, right? There's pressure over climate change, as aptly highlighted earlier today. There's pressure over plastic waste. There's pressure over product safety and environmental impact of our operations and of the products that we make. The brand owners that are at the end state, usually the ones touching the consumer that take our building blocks and materials, are exposed to these pressures as well. They're seeing for the first time significant sustainability threats to their products. They're all under pressure to increase sustainability pledges and commitments. There's broader value chain that's being engaged to address the issue. And I think as aptly highlighted by Ahmed, there are significant technology gaps that limit implementation of solutions in this space. The regulatory environment is under considerable pressure. And I'll just highlight, the ban on plastic imports in China, the focus around SEEK in KSA and driving energy efficiency and carbon management. And of course, many of you have also heard about the Green New Deal, which is another significant driver. And with our election in the US, we will see what the future holds for regulatory environment in the United States. But the reality is we're seeing a rapidly changing environment, and companies have to act and take a leadership position. Not only are these pressures there that are, I would say, more consumer value chain or regulatory, but you also see financial capital now being impacted. And I just highlight this one example from BlackRock CEO Larry Fink that highlighted that climate change is driving a profound reassessment of risk, and we anticipate a significant reallocation of capital. You see significant movements in the financial sector and reallocating capital towards companies that are balancing that risk to ensure that their futures are sustainable from an investment perspective. So for the chemical industry, like what does the CO2 footprint challenge mean? What is really the issue for the chemical industry? To give you a perspective, industry itself accounts for about 25% of the greenhouse gas emissions, just highlighting the IEA data from 2018. And of that industry, chemicals represent about 24% of that. So it gives you a perspective that 24% of the 25% of the total is really what represents the impact from chemicals. So it's sizable, as are other areas like cement, like aluminum, iron and steel, like transportation, obviously. But it is sizable from the chemistry perspective, and we need to address it for chemicals. Where do those emissions come from primarily? I think we can get lost in all the different products that are made from chemicals, but the reality is that almost 60% of the emissions come from the production of light olefins and aromatics, methanol, and ammonia. So when you think about the problem and you want to try to address the challenge, if you don't address it for these building blocks, you're not going to address driving towards a circular carbon economy. Now, one thing that's often misunderstood is that many people think that the reason that there's a CO2 emission industry in chemicals is because of the byproducts that you make in the reaction itself, low selectivity, poor conversion reactions. But the reality is that only 15% of the carbon is produced directly from the chemistry itself. 85% of the carbon and CO2 that's produced is produced as a result of the energy needed to drive the reactions that we use. So this is really, at the end of the day, not a chemistry problem, but it's an energy problem. It's the energy needed to drive the conversions that we make. So I wanted to start you with that sort of understanding as we talk about what I'd like to highlight today is what are the best approaches towards addressing that issue for the chemical industry, and what help do we need? To just give you a perspective, and I'll do a quick thermodynamic lesson for those students at KFUPM that want a little refresher on thermodynamics, but I'll use the example of methanol. So in methanol, if you just look at the step equations here, at the end of the day, you're taking methane and oxygen and you're producing methanol, and that's a highly exothermic reaction. Very beneficial in terms of its energy expended. If instead you say, I'm gonna use CO2 as a feedstock. So what's the challenge with using CO2 as a feedstock? Well, the challenge is if you build the same equations, and instead you use CO2 as your feedstock to get that oxygen into the methane, what you end up seeing is that this is now a highly endothermic reaction. So now we're going from something that's negative 504.5 kilojoules per mole, now something that's endothermic by almost 300 kilojoules per mole. So what's the result of that? Well, the reality is that means you've got to add more energy into the equation in the form of methane or whatever energy source you're using to drive that process versus the above case. And the result of that is you produce 1 extra mole of CO2 than in the previous case. So 1 mole of CO2 is used in the feedstock. That's the benefit. But you add 1 mole of CO2 in the emissions. So this is inherently the challenge with CO2, right? It's a material that has the potential to be used as a feedstock, but inherently, because of its energetics, to convert it requires a significant amount of energy. And I think that's why this focus on renewable energy is so essential to the discussion that we're going to have today. Like, we can't really change thermodynamics. There are a lot of things that we can try to change, but thermodynamics is really there to have an impact on us. Whenever we chemically reduce the carbon and CO2, we need to add energy. That's as highlighted on the previous slide. This energy can be in the form of hydrogen, and we're going to, I think, probably today spend a lot of time talking about the hydrogen economy. Ahmed, I think, gave a lot of great examples on that front. Or it needs to come from other energy sources. Catalysis, which is a critical enabler towards chemistry and selectivity, doesn't solve the thermodynamic challenge, right? Catalysts can't address thermodynamics. They can significantly reduce the energy needed to convert the CO2. They can affect the kinetics, they can affect the selectivity of the reactions, but they can't change what is necessarily a thermodynamic challenge. The key is looking for ways to use renewable energy, right? Renewable energy, which can give us a carbon-free source of that energy, whether in the form of hydrogen or other energy sources, is what's going to be essential to delivering on using CO2 in an effective way to drive a circular carbon economy. Or, as highlighted, to reduce the production of CO2 in the first place. And we'll highlight both examples of both of those here today. So, can process electrification be enabling for circular carbon economy? Well, uses of renewable energy in chemical plants are abundant, and actually there are many more ways that we could use renewable energy to electrify parts of our assets. I'll give a few examples here. E-drives for pumps and compressors. These are actually more energy efficient than steam drives, and they're already commercially proven for petrochemicals, but it requires retrofitting of existing assets. Same story for e-heaters, e-vaporizers, and boilers. In many cases, these are 10% more energy efficient than combustion, commercially proven in other industries, and they require scale up and validation for the petrochemical application. And lastly, which I think has the biggest potential, but also maybe the most technology transition that has to occur, e-furnaces for endothermic reactions, looking at cases like SMR and steam cracking. These are also more energy efficient than combustion. They're used in other industries, but there is significant, back to the TRL discussion that Ahmed raised, significant development and demonstration needed for the petrochemical applications. But this is a way to provide direct use of renewable energy to offset the carbon emission, thereby giving a direct reduction in the CO2 footprint from the petrochemical assets. Now, I think one of the things that's also been highlighted earlier today, but also I'm sure will be discussed through the session, is there's been a dynamic change in what's in the availability and the cost of renewable energy. I think really well highlighted in Ahmed's presentation. You see, just as an example here, the growth on onshore wind power generation, the growth in solar power generation capacity, and the total installed cost, right, which has dropped tremendously over the last decade. The reality is full petrochemical plant electrification could enable up to 100% reduction in CO2 emissions, 20 to 50%, depending on the asset and the technology, reduction in specific energy consumption. But despite this radical change in availability and cost for renewable energy, if we rapidly grow displacing energy sources with renewables, it will lead to likely some expected cost and availability challenges for the near to midterm, right? So we have to be prepared to how do we implement renewable energy in a way as we go through this transition. I think, as well highlighted by Ahmed, long-term, I think we see a long-term low-cost position that can be very enabling, but we're going to have to make sure that we use it the most effective way possible in this interim period. So I'll just give one example as how we think about this challenge at SABIC and how we're addressing it. And again, I'll use the methanol example. And what I really wanted to highlight here is just the example of the traditional approach to making methanol on the left-hand side. We have a power plant. It produces electricity. It produces CO2. We use some of that power to support our chemical plant. It brings in methane. It produces CO2, and it produces methanol. I think pretty straightforward, right? You produce a 0.5 kilogram of CO2 per kilogram of methanol using methane, or 3 kilograms of CO2 per kilogram of methanol if you're doing it based on coal. So this just gives you a perspective. If you instead follow the top route, which would be the sort of traditional hydrogen economy approach, then instead you produce CO2 from whatever source. I use the example of a power plant here, but you produce CO2 here. You produce hydrogen using renewable energy through electrolysis, and you use the hydrogen and the CO2 to generate the methanol. This actually is a favorable process, and it can provide you potential savings of about 41 grams of CO2 per megajoule of energy. So this gives you a perspective. If I'm trying to look at the most efficient way to use the renewable energy, then what I want is the most grams of CO2 per megajoule. A comparative approach is just doing electrification of the steam methane reforming process itself. So I use a renewable energy source. I take the electricity from that and I actually change my furnace to an e-furnace, and I produce the methanol from methane directly this way. So the reality is this approach, which is a more direct route of electrifying the SMR process, actually produces a savings of 74 grams per megajoule. So it's not that the hydrogen approach is not sufficient. It's actually a very favorable process, but it's more efficient and produces more savings of CO2 per energy used by just directly electrifying the SMR. So these are the kind of things, each process, each technology will have its own subtle differences, but it's very important that we look at these as we make sure that we get the maximum impact from the renewable energy that we apply. I'll just highlight that on the example here. You saw the two references I had to the 74 and the 41, but this just gives you a schematic of a number of examples of ways that we can mitigate CO2. I start with actually the highest, which is displacing a coal-fired power plant. I mean, let's not forget that whatever we do in chemicals, we need to address the energy and the transportation footprint. And I think clearly here, displacing a coal-fired power plant would be the most impact you can have. As highlighted earlier, displacing a coal-based methanol plant would be the next worst from a chemical perspective. You compare that to the methane-based methanol plant with an e-furnace or the hydrogen approach, you can see a steady reduction of impact. But this just gives you a way to think about the different areas where you can have an impact and where the chemical routes sort of stack up in comparison. And when you think about our sustainability priorities at SABIC, I mean, this is how we've mapped our materiality for sustainability. And it really falls in four major pillars across the top: resource efficiency, right? Driving our ambitious goals to reduce material loss intensity and water intensity; climate change and energy, focusing on our SABIC ambitious goals to reduce greenhouse gases and energy intensity; our innovation and sustainability solutions, ensuring, as highlighted by Aramco as well, that our R&D engine is aimed at delivering sustainable solutions that can help enable resource efficiency, climate efficiency, climate reduction, and circular economy. And then lastly, focusing on developing solutions for the circular economy. All built, of course, on a foundation of governance, integrity, and environmental health and safety, but very focused on these top four pillars as our sustainability drivers. Just a few examples of some success stories around the circular carbon economy concept from our side. I mean, number one, energy efficiency, I think as highlighted by Ahmed as well. Energy efficiency is stuff that we need to do today. We need to continue to drive efficiency of our assets. We've seen an improvement of energy efficiency by about 11% by implementing over 170 projects with a total investment of over $4.5 billion Saudi Riyal over the last 5 years. Successfully reduced our greenhouse gas intensity by 13.57% since 2010, with a plan to achieve 25% by 2025. And we've collaborated with the SEEC and closed 80% of our gap between the performance targets for the 2019 first cycle. We're very focused on renewable energy adoption for many of the reasons that I highlighted earlier, setting our ambition to install renewable energy capacity of 4 gigawatts by 2025, aiming for a 50% energy mix from renewables, and establishing a close collaboration with organizations like REPTO and ECRA, and leveraging available and future energy sources to create green chemistry solutions. I highlighted our asset electrification efforts that I focused on earlier, but also advancements that will be coming with NEOM and others. Circularity of our solutions as well, right? Focusing on how to get more resource efficiency for the products that we make. Many of you maybe have heard of our True Circle initiative, but it's really around delivering a circular set of solutions around plastics. And lastly, CCU realization, right? I mean, CCU, I think is highlighted in CCS, as highlighted by Ahmed, is going to be part of the solutions that we need. We're going to have to address the CO2 that we make, and find valuable ways to either store or convert that where feasible and fitting with the thermodynamic and economic boundaries that I highlighted earlier. We have set up and are now running the largest CO2 utilization plants in Jubail, successfully turned CO2 into methanol and urea. And as well, we demonstrated the first shipment of 40 tons of high-grade blue ammonia to Japan for zero-emission fuelization in collaboration with Aramco and our partners there. These are just examples. It's really going to take work across all these, and I kind of map these out here, much like Ahmed did in the 4 Rs, right? And I think it's very essential. I think it's well highlighted by him, the simple concept, but is a powerful one of where to put the priorities. In our view, they go in this order. Number 1 is to focus on reduction. Looking at the use of bio-based polymers, which we have in our TrueCircle platform, looking at the use of renewable energy, at furnace electrification, leveraging tools like high throughput to get more efficient in our processes, leveraging technologies that we've made investments in, like Q-Pinch for energy efficiency, MTEX for separations, and as well partnering with other companies on low carbon emitting technologies to the World Economic Forum to develop partnerships necessary to bring some of these solutions that are in the lower TRL levels to advancement into the market. Focusing on recycling, whether it be mechanical or chemical recycling, our advancement with the Alliance to End Plastic Waste and the World's Plastic Council, and then reuse, ensuring to get the most effective reuse of the materials that we produce. And then of course, lastly, but still very important, addressing where we can't solve it through reduction, recycle, and reuse, how do we best remove the CO2 from the system? As I just end here, I just would put the challenge out to the academic community specifically, but also broader, what do we need to be successful? From the science and technology side, we need investment. We need to grow talent. I think a great reason that we're here with KFUPM today and the inspiring talk at the beginning by Dr. Sagaf on what's happening at KFUPM. We need reaction engineers. We need separation expertise. We need materials processing. We need catalysis. We need modeling. We need digitalization and advanced data capabilities. We need to drive a science-based prioritization. We need to focus on the most impactful solutions to addressing climate and CO2, and we need to provide that clear scientific direction to the academic community as well. We need to invest in breakthrough R&D and technology demonstration, whether it be electrification, energy storage, recycling, bio-based feedstock, and of course, hydrogen, CCS, and CCU, but again, in that order of prioritization based on the thermodynamic constraints. Policy, finance, and infrastructure, right? We need the availability of financial capital to de-risk these earlier stage technologies. We need sound policy and regulatory frameworks to catalyze the value chain investment. We need enabling infrastructure, especially increased renewable energy investment, reliable renewable energy grids, expanded grid capacity. These are all essential. CO2 storage and transport, and of course, bio and recycled feedstocks. And lastly, as we look at the regulatory environment, recognition for the Scope 2 and Scope 3 greenhouse gas emissions that our companies produce. And lastly, collaboration, right? This is not something that one company, one industry can solve. We have to have industry, cross-sector, and public-private collaboration. We've got to address the regulatory, finance, technology, and market hurdles, and we have to do that together in ways that maybe we haven't been comfortable collaborating in the past. And the academic partners like at KFUPM and others are essential to bringing that vision to a reality. And with that, I will conclude and thank you for the opportunity to speak to such a great group.
Thank you very much, Bob, for really also excellent and insightful talk. We'll take maybe a couple of questions. If you allow me, maybe the first question will go to Dr. Sagaf. You mentioned about that KFUPM is becoming now independent. So what independence, what are the challenges and opportunity coming with the independence of KFUPM, especially, and we are talking about the opportunity in industry, in clean energy as we talk here, and other avenues, and we need to grow talent as well. You are muted, Dr. Muhammad.
Thank you very much. Well, more opportunities than challenges, but there are challenges. In fact, whenever you start taking an approach to capitalize on opportunities, new challenges arise. The opportunities are flexibility and speed. And this is something that I promised everybody I have met since a year ago, and Ahmed has heard it before. Unfortunately, he keeps hearing repeat, speeches, because we are we participate together in more than one workshops, and plus he's a 1984, I think, as well. So it's the same. It's the same. So fast and flexible. This is really what KFUPM needs to be in order to capitalize on the new independence. And we have been doing that. We have reduced the approval authority of many things, from ordering books to approving new programs. It used to take us a long time going through multiple approval stages to approve one new program. In fact, on average, the university has approved or revised, approved revision or establishment of a program only 4 times a year on average over the past 10 years or so. And in the last year, we revised and created 70 programs, 35 curricula, 20 concentrations, 15. To some, it was a shock. Even when we told our advisory board, they said, we don't believe it. Where did you get the money? It must be, without the money. We said, well, the money is going to come from Aramco and SABIC and others, I hope.
Well done.
This is what Ahmed and Bob have been promising us. When I met both of them, I met them at least a year ago. So, but fast and flexible, not furious and flexible. This is really what KFUPM needs to do, and flexible in many things, doing things quickly, and we have proven that we can. And we have proven to ourselves, I think, more importantly than proving to anybody else, that we can. Well, sometimes you don't believe that you can do things. And also, we have proven to ourselves that fast does not mean low quality, because there is a misconception that if you do something quickly, it must not be robust, and especially in academic settings. Yesterday, or 2 days ago, I was in a meeting with almost all presidents of Saudi universities, and one of them said, well, you cannot do this, develop new, it takes us 10 years to develop a new program. I was thinking to myself, that doesn't take 10 years. You can do things quickly and robustly, but they have to be done with the right people and in the right setup. So the challenges are many, because the university have been relying on some support from outside, from the Ministry of Education and so on. And that support is including sending people for scholarships, our international exchange program and so on. And we have to develop new ways of supporting these programs now that I don't think they will be forthcoming from the traditional sources, but really fast. And I saw a question I will answer later if you select, about admitting graduates, students and foreign students.
Go ahead, please, Dr. Muhammad. You can answer that for me.
Well, the question was, what are we, as we are becoming independent, we also are changing the way we attract students. By the way, this year in particular has been a low for attracting international graduate students. It has been because of the pandemic, and because of it has been, and because in the past we have relied on really, in my view, not a very effective way of attracting the best students, in terms of how we attract them, in terms of how we advertise, and in terms of how much we compensate them. And so we are overhauling this. So we are going to strive to attract the best graduate students. And this is a call to all the professors here from across the globe. You can recommend us the best graduate students. We are going to compensate them properly. And we are going to get them visas quickly. And we have experimented with this now that we have this legal separation. We're able to get visas for graduate students in a matter of days, whereas it used to take a long time before. We are also opening our doors for undergraduate international students. We are not going to get a lot of undergraduate international students, but we want to enrich the culture of the campus. Somebody from, just like Kaus from Mexico, or from China, or that also is something new that we would like to do effective next year that we haven't been able to do. So we are opening up. We want to be an international global universities. We are reducing the barriers to this year. Even our non-Saudi students, the university decided to give scholarships to them. We selected the top 20 and we gave them scholarships from the university. So they are treated almost like Saudi students in terms of stipend and so on. And the rest that we admitted, those are the ones who grew up in the kingdom. We arranged for donations to support those who need the scholarship. So we want to be open. We want to attract a mix of students from across the globe. And next year, there is a plan to start admitting also females to undergraduate. And I hope maybe next year, maybe the year after, we'll see. And so fast and flexible and open to everyone. And we hope that we will admit many new graduate students. We need them. Not only do they need us, we need them in order for our research programs to be lively and productive.
Thank you very much, Dr. Muhammad. I'll have one question. I'll combine maybe one or two questions for Mr. Ahmed Al-Khwater. Why, although maybe you talked a little bit about it, but why it is really important for Saudi Aramco to invest in clean energy, especially that it's heavily depending on the, crude oil and other things. And what are the efforts of Saudi Aramco in sustainability and clean energy and carbon capture with the other big companies in the world?
Great. So just to say, why do we need to? I mean, I think the challenge for the world is to reduce emissions, and Aramco is really a contributor to that challenge. We are working to solve that challenge with the rest of the world. So we see it as our role to really develop solutions that will enable the sustainable use of hydrocarbons. We believe that hydrocarbons, and I don't like the term clean personally, I like low carbon rather than clean, because I think hydrocarbons are clean. Hydrocarbons, it depends on how you use them. So the emissions that we talk about, and in CO2, in fact, is a greenhouse gas. It is not a health challenge. It is an environmental challenge in the terms of climate change. But so is H2O. Water is a greenhouse gas as well. So the term clean has some connotations that I don't like. But let's just say low emission, and we recognize the world's commitment to a lower emission future. And so, how can hydrocarbons play a role? For us, we believe that there is a role for hydrocarbons a long time in the future. We know it has been the basis of an energy system for the last 100 years, which has revolutionized the world and really driven progress. Energy, as Dr. Sagaf mentioned before, goes into everything we do. But I think beyond energy, hydrocarbons in our business is, as you know, is also in materials. 57%, yes, of hydrocarbons and oil specifically goes to energy, to transport. But 17% or so goes to other materials, for example. And so we believe that there is a place for hydrocarbons and oil in many sectors beyond transport and even beyond energy use. That's going to grow continuously. And it's actually going to be an enabler for the new energy system. So much of the objectives of the world towards meeting the emissions targets that they have set are going to be met, like I said before, with materials, new materials. And it'll take scale up, tremendous scale up. If you look at renewables alone, renewables today represent only a few percent of the total energy mix. Now, if they're really going to reach 80% or so, that means huge capital investment in hard materials, actually, a lot of material input. And that applies to, that's just the source of the energy, the electrons. But then the actual use of them, whether it's batteries, whether it's electric vehicles, all of those are going to take basically carbon-based materials. And so we see much more material growth over time. into the future, and we'll be part of that material growth. As you see, as you know, we have are now the majority owners of SABIC, and we believe that SABIC is going to lead a lot of those technologies that we feel will be, basically growing new markets for hydrocarbons ultimately. So that's what our strategy, and it's very, we're very transparent about our views on the future of oil. Our CEO always emphasizes that point, that we are going to work to make our energy lowest emission energy. Today, an oil barrel from Saudi Aramco is the lowest emitting oil barrel from any major oil producer in the world. With every barrel we produce, we emit around 10 kilograms of CO2. That compares to a global average of about 40 kilograms of CO2. So we're far ahead of the rest of the world in reducing emissions associated with our oil. And as the world will need oil, we believe into the later, from decades to come, it is natural that we will try to utilize the oil with the least emissions, and hopefully with zero emissions in the production. So we're looking forward to reducing those emissions associated with production of our oil. We're already the lowest, and we can go lower. And by the way, it's also good business, by the way. The fact that we have the lowest emissions is a reflection of the fact mainly that we use the least energy to extract our oil. And energy is the cost of that extraction. So we also have the lowest cost barrel. It's not a coincidence that we have the lowest emitting barrel and the lowest cost barrel. So it is good business practice to reduce emissions associated with your production of your product. And it's good environmental practice. So that's our view, that we will be contributors to a sustainable future. We do believe in technology, and that it's an emissions problem and not a fuel problem. It's not the source of the fuel, of the energy that's the problem. It's really what we do with that energy. So we are working on efficiency technologies that will take combustion, for example, from the average of 30% up to 60%. That will be a tremendous reduction. And as Bob pointed out, it's not the immediate application. Efficiency can have a tremendous effect, a much greater impact, in fact, than direct utilization of renewable electricity, for example. So we look at, like Bob mentioned, electrification of our facilities. That is going to have a huge impact, actually much greater CO2 impact than, say, conversion initially. But long term, as the cost of renewable electricity goes down, I believe that it will make sense to do direct conversion of electrons to chemicals. And that's the economics, whether it's, it may not be the most efficient route, but the economics may drive us that way.
Okay, thank you very much. Maybe the same question to you, Bob, plus you mentioned about also the storage challenge as well. So if you can also elaborate on the storage related challenges.
Yeah, look, I think Ahmed really covered, well, both the Aramco view and the SABIC view on the first question, really, which is, why the focus here. The reality is, our job is to provide the most efficient conversion of our materials into the building blocks, and from an economic perspective, provide the best economics for doing that conversion. And the energy dynamic that's changing drives us in this direction. The risk around emissions and managing those emissions and costs all push us to a spot where this is an area where we not only need to participate, we need to lead, right, to drive a sustainable economic picture for SABIC for the future. I think really like what Ahmed said about, the hydrocarbon role in the chain. And I think one thing that's missed in chemicals is that they are by far the most efficient way to get to ethylene and propylene. You could start with biomass, you could start with CO2, you could start with lots of things, but the reality is we use the most efficient material to make the most efficient products today. And there's a reason for that, but we do need to lead in terms of how do we address the emission challenge? How do we address more efficiency in our operations? How do we address the balance between when you have to remove versus how you can reduce the production in the first place? And it's important, if we're going to drive our industry forward and make sure that the value chain and the consumer accepts our products and the solutions, we really have to take some aggressive steps to leverage technology to make ourselves competitive for the future. So we definitely see it as critical. Now on your question of storage, I think there are a few challenges. I mean, one of the challenges with renewable energy is the continuity of supply, let's say the sustainability of supply, right? We need to make sure that we have a reliable and stable grid and a sourcing of electricity, which means that as you go to higher and higher levels of renewable energy, you're going to have to manage storage as part of that, and whether that storage is through chemical storage or batteries or whatever solution you're going to apply, ensuring that you have a constant supply of that energy source to maintain your operations is going to be essential. And this is actually a huge challenge for the integration of renewable energy into the chemical sector and into oil and other sectors as well. Is how do you build the right grid capacity and the right ability for that grid to handle your on and offs in your production. It's one thing I'm very proud of our engagement with the World Economic Forum, because we're working very closely with the electricity producers globally as well to think about how the industries are actually going to connect together. Storage is a big piece of that, but also probably rethinking our assets and configurations for the long term about how you can operate with more volatility in your supply. So I think there's a lot of interesting technology challenges over the next few decades, but storage, process innovation, and control systems and leveraging tools to help optimize operation are going to be critical pieces of that future state from my view.
Thank you very much. I just one maybe final round of questions because we are already over the time. I will start again now with you, Bob, since you were the last one to be asked.
Sure.
The question is about plastic recycling. How much now we are in plastic recycling in SABIC, basically? How are we doing in this regard? Yes.
Yeah, obviously for us, it's a priority, and actually it's actually an area between Aramco and ourselves that actually a lot of collaboration developing also. We started the first chemical recycling production in Europe, and are selling products on the market where we leverage chemical recycling. And we are engaged in a global strategy now in the Americas and KSA and Asia and in Europe on how do we scale that and what are the different models. We think it's critical. Again, this question of the plastics and circularity is not an open question anymore. The value chain, the consumer, the brands are expecting solutions. We have to do so in a way that's affordable, that provides an investment economics for those upstream of us on the waste side, but also where the value chain can absorb the costs of the conversion itself. So we're very active in engagement upstream on the waste side, on technologies to drive the cost for chemical recycling down, to balancing mechanical and chemical recycling solutions and ensuring that our products help enable mechanical recycling as well. And one example of investments, you're probably familiar with the Saudi Investment Recycling Company in KSA. I mean, we have key membership roles there and are very engaged in actually helping to make that come to fruition, specifically in the kingdom. We're building the right models for recycling there, but this is a global effort where we're doing this in each region. I think you're going to see, for example, from our side, more announcements around scaling up of our chemical recycling technology, but also advancements in mechanical recycling, design for recycling, where we can actually make packages and products that reduce the amount of material needed, and through partnerships like in non-metallic with Aramco, looking at where we can drive more efficient use of plastics that are more efficient and more friendly applications for those products as well. So you'll see a lot of activities from that on our front, but it's a critical priority for us, and not only our sustainability priorities, but actually from the business itself, right? It's a critical business strategy item. Thank
you very much. Next question to Ahmed. Regarding energy efficiency and especially in marine transportation, how is Aramco doing in?
Interesting. So actually, the interesting thing is marine transportation is probably your most efficient transportation. The large two-stroke marine engines are technically the most efficient. They about average on 50% efficiency in combustion. So in fact, it's hard to advance the large marine engine efficiency, and they also have the lowest cost fuels. So they actually have the greatest challenge to decarbonize because they're already the most efficient and they use the lowest cost fuels in the form of bunker fuels. So as you've seen, there have been a number of interesting research projects to how to reduce the carbon footprint. Some of them include, for example, hydrogen, and some are actually utilization of ammonia, which is a very interesting molecule. As you know, it has no carbon. And it can actually be a drop-in fuel with, some storage challenges. But other than that, it combusts readily with some support in a conventional internal combustion engine or a reciprocating engine. So it has I think if we looked at the decarbonized fuels, that's probably your best opportunity long-term to have a decarbonized fuel in the marine sector. And I think a number of companies are looking at that around the world. There are those who are advancing lower carbon, say LNG, liquefied natural gas. There's a challenge there. We've looked at that ourselves. It is in that LNG is got a kind of a hidden carbon footprint, let's say, because of leaks and others. Methane is a challenging gas in the whole supply chain. But even if you do solve the supply chain leaks, which we have, by the way, Aramco is also the lowest, one of the lowest in methane leakage. We're at 0.6%, so which is one of the lowest in the world. But even then, in the use, there's the slip in the engine, which is very challenging. So the slip of methane in the engine creates, as methane is a very powerful greenhouse gas, it makes it a very big challenge. We think there's actually great opportunity for mobile carbon capture on ships. So we have been advancing the concept of capturing your CO2 from the exhaust for many years. We developed an earlier technology for a light duty vehicle. And then we did it for a heavy duty vehicle where we capture 45% of the CO2 from there and store on board. And in fact, that is really appropriate for very large ships which have limited ports of call because there's an opportunity to offload the CO2. So this is an area that we're also working with the Oil and Gas Climate Initiative, which is a group of oil companies. We have a study going on with a number of ship operators and manufacturers to look at these opportunities, the different options that are out there to decarbonize and to lower the carbon footprint of ships. So I would say that the technology is, it is an old technology for ships, but it's actually quite efficient. And what we're trying to do actually is bring the auto industry to actually try to match the shipping industry's technologies in the form of, for example, the posed piston two-stroke engine, which we worked with a company called Acades and brought their efficiency up to 45 plus efficiency in a conventional engine. So really, there are opportunities to bring what I would say the laggards in the internal combustion engine technologies to the marine industry's very high efficiency ultimately. But beyond that, we need to look at lower carbon fuels or carbon capture and recycling.
Thank you very much, Dr. Muhammad. How the whole ecosystem at KFUPM from education, research, entrepreneurship works, plus lots of questions about the employability of these new concentration at KFUPM. Of course, this question it may go also to Bob and Ahmed, but maybe you can answer also in general, Dr. Muhammad.
I think for the university to really make an impact, one very important hurdle that we have to overcome is talking to each other. I think interdisciplinary research, interdisciplinary teaching, interdisciplinary discussions in general are key to the future of the university. And this is an area in which we have not done very well. Academic, in any organization, people tend to congregate in their own groups, and after a while the group becomes focused, and then they forget about building bridges, and so that is a challenge for the university. This is why when we started the concentrations and the next programs, we said these are interdisciplinary. We ensure that every committee that develops them is interdisciplinary. The first question is, who are the committee members? And then we ensure that all the courses there is not a single MX or concentration that has courses from one department. Oftentimes from 3, sometimes from 4 different departments. That is a culture that will take some time, but the university is adopting it and embracing it really very, very well. The next challenge is to ensure that we have it not only in academic programs, but in research as well. we are doing things even in the evaluation of our faculty and researchers. The new evaluation system will focus on whether you had taught in courses from outside your departments, whether you participated in projects from outside of your research center. And so this interdisciplinary approach is key, I think, to the ecosystem, because it will make the engine much more efficient. Most of the inventions in science and technology come from a topic that you borrow from somewhere else. I know this very well. I'm a geophysicist, and one of the greatest geophysicists in the world is Dr. Anders Robinson, who invented geophysical seismic deconvolution and analysis in general, and he borrowed this from economics. He saw the economic innovations and how they can be decoupled into a response and a wavelet, and he used it. And so that is a very important driver. This is why every center that we are going to create is called interdisciplinary center. And somebody yesterday said, well, the name becomes very long. It doesn't matter. It has to be in your name that you are an interdisciplinary center and drawn from multiple 10 departments in some of them. So that, I think, is the future of the university. Employability, we want to be on ahead of the curve. That is what KFUPM wants to be, ahead of the curve, not after the curve. But it is a difficult balance. For example, quantum computing. Do we need quantum computing? Well, you talk to STC, they say, yes, we want quantum computing because we are getting into new forms of processing, and the way that some of the problems are parallelized and so on. And we are moving from a telco, because you will not survive as a telco, into a fintech company. In fact, they are now the 6th largest bank in the kingdom. I know very few people know this. But we had difficulties attracting people to that concentration. Hydrogen mobility. Well, I live next door to Ahmed. He's my very close neighbor, and in front of his house there is a hydrogen car. In fact, I borrowed it once from him. He uses it every day. We at the Dhahran Techno Valley, we have a hydrogen station for filling gas. This is going to be the future. We want to prepare students to take up jobs of the future. But when we said hydrogen mobility, no one in the students knew what this is. We had to talk to the company that I always
Air Products.
Air Products, and they came and worked with us. And then when we saw no interest from the students, I called on to their president, and he was very kind, and he said, okay, we'll sponsor 10 students in hydrogen mobility. I also called Ahmed, by the way, but the money came from Air Products, and we got some students. Is it going to continue next year? I think it's a question that we need to ask ourselves. I hope that it continues, but if the students don't see immediate, by the way, all of those students graduate with their official degree. So they have this already in the bag. If you are a chemical engineer, you have a degree in chemical. That is only the icing on the, instead of having fragmented electives, your electives become concentrated and focused. And so, but if they say experimentation is the essence of science, that is also part of the philosophy of KFUPM. We will make experiments. Some of them, just like in research, will succeed. Some of them, they will fail. If we see next year that hydrogen mobility, quantum computing don't attract students, we will defer them for a few years until that discipline is established. But we do want to be ahead of the curve. This is why we are focusing, like I said, on new materials. Before someone in Aramco says we want this, we will say, yeah, it is available. And or in SABIC, before they talk about a certain aspect of catalysis, we already have a program and the mixing catalysis and so on. And Bob mentioned a few of these new disciplines. We are open to all of them, but we cannot do it alone. I mean, we have to have the industry with us. I honestly say this, not the industry with us in terms of money, no, the industry with us in terms of participation, coming to us, designing. Yesterday, there was a meeting between the College of Environmental Design and the VP of Project Management in Saudi Aramco, because we said we are launching a new MX in project management and we need to take that input. We didn't have this close interaction in all the programs. I have to just be candid. We want that to be the case, such that our programs are enriched. So the short answer is we want to be ahead of the curve. Sometimes you are too much ahead of the curve and you need to slow down, but it is better doing that rather than being behind the curve. And like I said, students are not hurt because those graduating with concentrations, they already have the degree. It's just an icing on the cake and specialization. And I hope Ahmed will hire some of the hydrogen mobility graduates. I think they study many things, and from how the hydrogen is generated, because we want in the kingdom for the hydrogen to come from naphtha and other sources rather than from something other than our commodity, to how it is used, to how to design its utilization. So very, very involved courses in the university. So yes, that's it.
Thank you all. I have really more questions, but we have really to stop. Thank you very much, Dr. Muhammad, Mr. Ahmed, Dr. Bob, for the excellent session that we have. So sorry also, Dr. Muhammad Darish, I think he is waiting for the next session. So, and apology that we took a little bit over the time, actually maybe 20 minutes, but next session, inshallah, will be with Dr. Muhammad Darish, and we will start at 10 a.m. Saudi time. Thank you very much all, and we'll have a break for about 9 minutes or so for the next session.
Thank you all.
Thank you.